Okay, this is part 2 of the lesson 8 video. There's a long video, 15.5 minutes you can watch, or this is in part 2, but we're picking up where we left off on this problem of how to take a parabola in what we call focus directrix form. That's right here. We call it focus directrix form because we can see the focus on the directrix. In this case, when it's y squared by itself, that's what it really should say y minus 0 there, but it doesn't. It says y squared. It really looks like y minus 0 squared. That's the directrix is that c value, that constant value, but we don't have it there. And then we see over here, we see the x-coordinate of the focus, and we see the y-coordinate of the focus. That's A and B. So it really is in that form, this whole process of going through this. If you want to see that again, how that was explained, go back and watch the first part of the video. Let's go actually back and try this, see what's going on here. Now that we kind of know how to do that, we can write the equation and then convert it into that vertex form. So let's give this a try. I'm going to try not to tap the iPad with anything but my pencil here. So let's write it. So y equals 0, that means that c is 0. So it's instead of writing y minus 0 squared, we're just going to write y squared as our left side here. Okay? On the right side, instead of writing x minus a squared, because that is our formula, we're using the x-coordinate right here. Well, we're just going to write x right there, because we do have an x. We don't have a point. This could be for any point on here. Instead of writing minus, we could write it as minus 3, because there's the x-coordinate of the vertex. That's A. In this case, it's now 3. Square it. And then plus y. There's our y comes from the point on the parabola. And the minus 2 squared. And if you remember, all of this comes from you're just really writing this as the distance formula from that. That's really, that piece right there is really this part of the equation right here. That's just the distance. It's really just the distance between those 2 points, except we're squaring it. We're just getting rid of the square roots, so we're making it easier to work with. And then we really have truly the distance going down the parabola from y down to the directrix. That's really, that right there is this y squared right here, even because it's really y minus 0 squared, but don't say y minus 0. So that's kind of where that stuff comes from. That's the setup of it. And since this is part 2, I have a little more time to think about this. I can actually now manipulate this algebraically, because that's what we have to do. That's what we learned in the end of the last lesson and the beginning of this one. We have to actually do the work here. So we got to dig in, roll up our sleeves, and that's what I'm actually doing. You can't see me, but I'm rolling up my sleeves of my hoodie here and saying, okay, let's get down to business here. Y squared. The x part, you don't touch. Don't touch it. Hey, don't touch. Leave it alone. Leave it, because that is actually, you can see here, if I said, what's the vertex? You can actually, believe it or not, you can see it. It's right here. I'm just marking it on the graph there, and I'm highlighting it in green. That's the vertex right there. We're trying to get that point and use it. So because you see a vertical line right there where that focus point is 2, that means the vertex point is going to be the same point. So we just leave it alone. That's the x's. That's the x piece of it. All right? Instead of being vertex at 0, 0, it's at 3 and 1. And we know that, so let's keep going. Okay? Soldier on here. The y's we said to expand. So that's going to be y squared plus 4. That's the first and the last terms. In the middle, it's minus 4y. And we practiced that in lesson 6, actually. So we've expanded the y's out, and we do know that something happens with the y squareds. We saw that last time, that y squared minus y squared cancels off. So we really, I'm okay, just cross it off. I know that's not mathematically, technically correct, but we know that if we subtract y squared from both sides, it goes away. All right? And then we know that what we want to do is we want to take all the y terms and move them. So we're going to take this, we're going to add 4y to both sides. So I'm actually going to show this. Why? Because we want to isolate y. That's why. Is that enough y's in one sentence for you? Okay, so we're right here. We're at plus 4y equals x minus 3 because what? We don't touch it. And that cancels. Then we got a plus 4 here. All right, last step. The last step is to do this. Divide by 4, or some people would say multiply by 4. I kind of like divide by 4 in my notation. And so what you end up with is this glorious y equals, and that's because 4 divided by 4 is nothing. Or I shouldn't say nothing, it's 1y equals. This whole thing divided by 4, we really usually write it as a fraction, 1/4 out in front. And that has something to do with the slope, but you'll learn that later. X minus 3 squared, still don't touch it. The x, we've left that alone from the beginning, and then 4 divided by 4 is 1. And now you can see the vertex. There it is. There's h, that's the 3, and there's k, that's the 1. That's what we're talking about over here. When we're talking about h and k, that's this vertex point, and we can now see it as part of our formula. That's the whole idea, is that we've taken a formula and we've done a little algebra to it, done a little solving. We've basically took that, and if you just had to say instructions, you'd say, find the vertex. Well, if you didn't have the graph, you'd have to manipulate the equation. You could also say solve for y, because that's what we did. Y equals. We just solved for y. All right, let's continue on here. That's the big message there. That's kind of it, folks. It's going to take us some practice. We're going to have to do a few of these. So that's why you need to show up to class, because this video is just for instructional purposes only, not tons of practice. But just a reminder on the summary, that distance, it's the changes in the x's squared, plus the changes in the y's squared. That's how you're getting the distance between the focus point and the point on the curve. And then the vertical piece in red there is the distance from that y coordinate to the directrix. Now, we have not yet seen a problem where that's actually happening. So let's continue on here. I got about 3 minutes left in this video. Let's write an equation, because that's all they say. To write an equation that states that x and y at some point is the same distance from the focus point, 4.1. It doesn't say that, but that's actually the focus right there. So we can just give it a name. And the x-axis, that's y equals 0. That's the directrix. All right. So to write that equation, we need to go with this general focus, because we got the focus, directrix, because we got the directrix, focus directrix form. That's y minus c squared equals x minus a squared, because that's what the focus point is. We usually use a and b, if you remember, as those coordinates, plus y minus b squared. All right, so we can just write the equation. No harm in doing that. Let's just write it. Shall we? We shall. So we're going to write it as y minus c. Well, in this case, c is 0, so we don't even write y minus c. We actually just write y squared. You could do that, but we usually just don't write y minus 0. And then we've got x minus 4, because that is our a part, squared. Don't forget the squares. Everything's squared. Always frame it up with squares. That's y minus b, and b in this case is 1. That's just writing the equation. That's it. Just setting it up. All right, so just that's really showing your understanding of what this equation means, what the moving parts are. Focus, a and b, first two letters of the alphabet. C, that's the directrix, y coordinate. All right, and then we come down to the last piece of this. These are just homework problems we're practicing on here a little bit. There's a focus. Select all true statements. That one I'm actually going to leave to you, because we're running out of time on this. We're down to 9 minutes, and I want to just, that's something for you to ponder, think about, and check the homework answer key in the locker. All right, bottom line. Let's wrap it up. Oh, stretch. It's yoga time. Been staring at the screen too long. And it's 1:30. It's beach time. Bottom line. You need to practice and understand the equation of the parabola in both the focus directrix form and the vertex form. This is not going to happen overnight. It does take practice. There's a lot of variables in there. They're pretty big equations. That's why we're in Math 2. We need to be able to quickly multiply out and square those binomials. That was lesson 6 where we did that. We practiced quickly expanding those. We need to do that quickly. That's not new learning. We need to do that quick. And then we're incorporating this idea of equidistant. And, you know, we've worked with the distance formula earlier in the unit. Now we're saying that there's two distances that are equal. And just like the circles, finding the radius, that was every radius was equal to, that was only one radius. Now we're finding two distances. And we're adapting that concept using parabolas. Or quadratics, that's what you call them in Math 1. When you work in algebra, you're calling them quadratics. We're calling them by the shape that they are, parabolas, because we're doing in geometry. All right, folks, blank screen. That means see ya, sayonara. It's not Friday yet, but it should be. So, that's not the wedge. That's Big Corona coming off the jetty on a foamer, except there's no jetty. We need to make a jetty here. Make a jetty. Okay. Anyway, I'm a math teacher, not an art teacher. See ya.